Harmonic resonance is a common issue when using switched power factor correction, or PFC, capacitors with adjustable speed drives, or as in the same building. Adjustable speed drives generate harmonic currents, primarily 5th and 7th order, which can resonate with the passive capacitors used in switched PFC units. The resonance frequency of the capacitor-inductor combination, or LC circuit, within the PFC unit matches the frequency of the harmonic currents, causing excessive voltage and current distortions. Symptoms of harmonic resonance can include swollen capacitors, tripped fuses, burning wiring, and overheating of PFC units. This can have an impact on PFC unit performance, such as reduced lifespan of capacitors, increased energy losses, overheating of components, and potential fire hazard. To mitigate these issues, several strategies can be employed. Firstly, install harmonic filters. Use passive or active harmonic filters to suppress the harmonic currents generated by the adjustable speed drives. Secondly, use passive PFC capacitors. Passive PFC capacitors have a fixed capacitance and do not resonate with harmonics. Thirdly, size the PFC unit appropriately. Ensure that the PFC unit is sized correctly to handle the harmonic loads generated by the adjustable speed drives. Fourthly, install line reactors or chokes. Inductors can be added in series with the PFC capacitors to limit the flow of harmonic currents. Fifthly, consider active PFC units. Active PFC units use electronic circuitry to control the capacitance and suppress harmonics. Sixthly, conduct a harmonic analysis. Perform a harmonic analysis of the system to identify the specific harmonics present and design mitigation strategies accordingly. It is also recommended to contact the manufacturer of the adjustable speed drives and PFC units for technical support and guidance. Seek professional assistance from an electrical engineer or power quality expert to assess the situation and recommend solutions. Regularly monitor the performance of the PFC units and adjustable speed drives to detect any potential problems early on. By addressing harmonic resonance, you can improve the performance and reliability of your switched PFC units and ensure energy savings in your facilities. Understanding the root causes and implementing appropriate mitigation techniques are crucial for maintaining a stable and efficient electrical system in facilities utilizing both adjustable speed drives and switched power factor correction capacitors. The interaction between these two technologies can lead to significant power quality problems if not properly managed. When adjustable speed drives operate, they draw non-sinusoidal currents from the electrical grid, injecting harmonic currents back into the system. These harmonic currents can interact with the power factor correction capacitors, which are designed to improve the power factor by providing reactive power. The combination of the inductive reactance of the power system and the capacitive reactance of the PFC capacitors can create a resonance circuit. If the resonant frequency of the circuit is close to one of the harmonic frequencies generated by the adjustable speed drives, a harmonic resonance condition can occur. During harmonic resonance, the harmonic currents and voltages are amplified, leading to a number of problems. The increased current can cause overheating of the capacitors, wiring, and other electrical components, potentially leading to premature failure or even fire. The increased voltage can also stress insulation and other sensitive equipment. In addition to the direct effects on the electrical equipment, harmonic resonance can also cause problems with the overall power quality of the system. The distorted voltage and current waveforms can interfere with the operation of other equipment, such as computers, electronic controls, and lighting systems. This can lead to malfunctions, errors, and reduced performance. To effectively mitigate harmonic resonance, it is essential to conduct a thorough harmonic analysis of the electrical system. This analysis should identify the frequencies and magnitudes of the harmonic currents generated by the adjustable speed drives, as well as the resonant frequencies of the power system and PFC capacitors. Based on the results of the harmonic analysis, appropriate mitigation techniques can be implemented. One common mitigation technique is to install harmonic filters. Harmonic filters are designed to absorb harmonic currents at specific frequencies, preventing them from propagating throughout the electrical system. There are two main types of harmonic filters: passive filters and active filters. Passive filters consist of inductors, capacitors, and resistors that are tuned to a specific harmonic frequency. They provide a low impedance path for harmonic currents, effectively shunting them away from the rest of the system. Active filters, on the other hand, use electronic components to actively cancel out harmonic currents. They offer more flexibility and can be adjusted to compensate for changes in the harmonic content of the system. Another mitigation technique is to use detuned reactors in series with the PFC capacitors. Detuned reactors are inductors that are sized to shift the resonant frequency of the PFC capacitor bank away from the harmonic frequencies generated by the adjustable speed drives. This prevents the harmonic currents from being amplified and reduces the risk of harmonic resonance. In some cases, it may be necessary to replace the switched PFC capacitors with fixed capacitors. Fixed capacitors do not have the same resonance characteristics as switched capacitors, so they are less likely to contribute to harmonic resonance problems. However, fixed capacitors may not provide the same level of power factor correction as switched capacitors, so it is important to carefully evaluate the trade-offs. In addition to these mitigation techniques, it is also important to ensure that the adjustable speed drives and PFC capacitors are properly sized and installed. Oversized adjustable speed drives can generate more harmonic currents than necessary, while undersized PFC capacitors may not provide adequate power factor correction. Proper installation practices, such as using shielded cables and grounding equipment properly, can also help to reduce harmonic emissions. Regular monitoring of the electrical system is also essential for detecting and preventing harmonic resonance problems. Monitoring equipment can be used to measure harmonic currents and voltages, as well as other power quality parameters. By tracking these parameters over time, it is possible to identify potential problems early on and take corrective action before they lead to equipment failure or other issues. Furthermore, the selection of the right type of adjustable speed drive can significantly impact the level of harmonic distortion injected into the electrical system. 6-pulse adjustable speed drives, which are the most common type, tend to generate a significant amount of harmonic currents, particularly the 5th and 7th harmonics. 12-pulse adjustable speed drives, on the other hand, use a more complex rectifier design that reduces the amplitude of these harmonic currents. Although 12-pulse adjustable speed drives are more expensive than 6-pulse adjustable speed drives, they may be a cost-effective solution in applications where harmonic distortion is a major concern. Another type of adjustable speed drive that is becoming increasingly popular is the active front-end adjustable speed drive. Active front-end adjustable speed drives use electronic components to actively control the input current waveform, minimizing harmonic distortion. Active front-end adjustable speed drives are more expensive than 6-pulse and 12-pulse adjustable speed drives, but they offer the best performance in terms of harmonic distortion. When selecting an adjustable speed drive, it is important to consider the harmonic characteristics of the drive and the potential impact on the electrical system. A harmonic analysis should be performed to determine the level of harmonic distortion that the adjustable speed drive will inject into the system and to identify any potential resonance problems. In addition to selecting the right type of adjustable speed drive, it is also important to properly size the drive for the application. An oversized adjustable speed drive will generate more harmonic currents than necessary, while an undersized adjustable speed drive may not be able to provide the required performance. The adjustable speed drive should be sized to match the load requirements of the application, taking into account the motor horsepower, speed range, and torque requirements. Once the adjustable speed drive and PFC capacitors have been installed, it is important to perform regular maintenance to ensure that they are operating properly. Maintenance tasks should include checking the capacitor voltage and current, inspecting the wiring and connections, and cleaning the equipment. Any signs of damage or wear should be addressed promptly to prevent equipment failure. It is also important to keep accurate records of the maintenance performed on the adjustable speed drives and PFC capacitors. These records can be used to track the performance of the equipment and to identify any potential problems. Regular maintenance and record keeping can help to ensure that the adjustable speed drives and PFC capacitors operate reliably and efficiently for many years. To summarize, Mitigating harmonic resonance in systems with switched PFC units and adjustable speed drives requires a multifaceted approach. This involves understanding the sources and characteristics of harmonics, conducting thorough system analysis, implementing appropriate mitigation techniques, selecting suitable equipment, and performing regular maintenance. By carefully considering these factors, engineers and facility managers can ensure that electrical systems operate efficiently, reliably, and without power quality problems. Remember that addressing harmonic resonance is not just about fixing a problem, it is about optimizing the performance and lifespan of your electrical equipment, reducing energy losses, and ensuring a stable and reliable power supply for your facility. Ignoring harmonic resonance can lead to costly equipment failures, increased energy bills, and disruptions to your operations. By taking a proactive approach to harmonic mitigation, you can protect your investment and ensure the long-term success of your facility. It is advisable to consult with qualified electrical engineers and power quality experts who can provide specialized knowledge and guidance in addressing harmonic resonance problems. These experts can help you to conduct thorough system analysis, select appropriate mitigation techniques, and ensure that your electrical system meets all applicable standards and regulations. Their expertise can be invaluable in ensuring the safe, reliable, and efficient operation of your electrical system.